All right, so we're going to draw the halogen in period 4. Now, how do I know how many, I should mention this is the second half of the video for drawing atoms and writing electron configurations, right? Part 2. All right, so we're going to draw the halogen in period 4. Now, again, so suppose we don't know what element that is. We don't know how many electrons it has. So how do I know when to stop? All right, I'm going to start at hydrogen, as always, but how do I know when to stop? Well, the halogens are Roman numeral group 7A. So I'm going to stop when I have 7 valence electrons on the 4th ring. Now, I'm never going to ask you to do this, all right? But I just want to show you how easy it is to do this. I used to have, every one of my high school students could do this, all right? But of course, I have them for, 160 days. I only have you guys for 28 or so. All right, so again, the halogen in period 4. So 7 valence electrons on the 4th ring, all right? So I'm going to have an electron counter up here, but I don't know how many electrons I'm going to need. All right, so I'm going to, as always, I'm going to begin at hydrogen. All right, period 1. So 1 ring down here. Period 1. Actually, I'm going to do this down here. Period 1, S block, and 2 electrons fit there. 2 electrons, hydrogen and helium. Okay? Now, if you want to, you can just write bromine up there. All right? That's all I'm ever going to ask you guys to do. Electron counter goes from 0 to 2. All right? I'm going to move a little faster here since this is all just a repeat of what we did on the last 2 or 3 problems. All right? So now my finger's on helium. Next element is lithium in period 2. All right? And again, if I'm going too fast, you need me to slow down, speak up. So there's lithium and beryllium. Period 2, S block, 2 electrons. Electron counter goes from 2 to 4. 2 to 4. My finger's on beryllium. Next element is boron, still in period 2, so I don't need a new ring. Remember, the ring is equal to the period number. Down here, electron configuration. Period 2, P block. All right, boron's in P block. 6 electrons fit in P block. Boron, carbon, nitrogen, oxygen, fluorine, neon. So here, period 2, P block, 6 electrons. Electron counter goes from 4 to 10. All right, so my finger's on neon now. Neon. All right, so now my finger is going to move to sodium, which is in period 3. So a new ring. A new ring. Down here, period 3, S block. And in S block, as we know, 2 electrons fit. 1 for sodium, 1 for magnesium. 1 for sodium, 1 for magnesium. Down here, electron configuration. Period 3, S block, 2 electrons. Electron counter goes from 10 to 12. Right? 10 to 12. So we're getting close. We're at the 3rd ring. We only got to go to the 4th ring. So the next element after magnesium, notice magnesium, alkali on earth, 2 valence electrons. There they are. So next element after magnesium is aluminum, still in period 3, so I don't need a new ring. Down here, I'm going to write period 3, and aluminum is in P block. P block. Okay? So I'm going to, we know 6 electrons fit in P block. So aluminum, silicon, phosphorus, sulfur, chlorine, argon. Argon. All right? So electron counter goes from 12 to 18. Down, oh, sorry, I forgot to put the 60. Period 3, P block 6, and then we write the 18. Do everyone the same order. All right, so now my finger is on argon. Argon. So the next element after argon is potassium, which is in period 4. Hey, we're getting close. We're on our 4th ring. We're on our 4th ring. All right, so down here I'm going to write period 4, S block. And I know 2 electrons fit there, potassium and calcium. There they are. There they are. All right, so down here I'm going to put period 4, S block, 2 electrons. Electron counter goes from 18 to 20. 18 to 20. Okay, and now we're in D block. Next element is scandium, which is in D block. But we know that we have to drop back one ring for D block. So instead of 4D, I'm going to write 3D here. 3D, period 3, D block. All right, and 10 electrons fit in D block. All right, now, some students like to use different colors. I do have different color markers here, and I'm going to assume we only have one. So this is why I use the triangles. All right, so from scandium, titanium, vanadium, chromium, manganese, 5 on each side, iron, cobalt, nickel, copper, zinc. Right, so there's 10, 3D10. And the electron counter goes from 20 to 30, 20 to 30. Okay? Now, I always like to stop at zinc. That's a good place to always stop and check. And we only need a couple more electrons. But again, if you're drawing like, you know, barium or something, this is a good stopping place to check and make sure. Because when you finish at 30 electrons, your finger should be on zinc. It's ending 3D, period 3, D block. Years in David. It's always a good point. And that's where we are. We just finished D block, and we're at 30 electrons. Okay? So the next element after zinc is gallium, right? Gallium, which is in P block. So I'm back to my regular period numbers. It's not 3P, because we already have 3P. So I'm going to write 4P here. 4P. Now, I know that 6 electrons fit in P block. We're on the 4th ring. We wanted the halogen, 7 valence electrons on the 4th ring. Halogen is 7 valence electrons. I already have 2, so I only need 5 more. So I'm going to write gallium, germanium, arsenic, selenium, and bromine. There they are. 4P5. And the electron counter goes from 30 to 35. 30 to 35. Okay? Now, before I count electrons, I'm going to rewrite this. No point in counting the electrons here if I'm going to rewrite it again. So I'm going to, what happened to my red one? There it is. I'm going to rewrite this. 1s2, 2s2, 2p6, 3s2, 3p6. And now I'm going to move this D electrons over to here. 3D, 10, 4p, 5. All right, now I'm going to count the electrons. I should have 35 total. All right, so let's see. I have 8 here, and 10 there is 18. And then there's 6 is 24, 30, and 5 more is 35. So I'm good there. Let's count them here. 2, 4, 10, 12, 18, 28. Uh-oh, what mistake did I make? See, I'm glad I made this mistake, and I didn't do this on purpose. Let's count them again. This is why you count the electrons. 2, 4, 10, 12, 18, 28, 33. Anybody see what the mistake?
You forgot 4s2.
I forgot 4s2. This is why you count the electrons. All right, we did all this work, get it right, and then rewrote it wrong. So let's see, where's my erasing? Here. This is why you always count the electrons. 4s2, 4p5. Now let's count. 2, 4, 10, 12, 18, 28, 30, 35. All right, so we're good there. The only other thing actually not the only thing, we should check valence electrons. All right, we're drawing a halogen on the 4th ring. So I should have 7 valence electrons on the 4th ring. There they are. Down here, I'm going to underline my highest period number. All right, there they are, 7 valence electrons. 7 valence electrons. Now, the other thing we should check is that we did, in fact, drop back one ring for the D electrons, so we should have 3D instead of 4D, which we did, and that we have 3D instead of 4D here. Okay, 3D instead of 4D there. Okay, everybody good?
Yeah.
Now, we're in
Yes.
position now to see why you drop back a ring for d electrons, right? So for our purposes anyway, right? Suppose I had made these 4D. So we went 4s2, 4d10, 4p5. This atom would have 17 valence electrons, right? It would have 17 valence electrons. But we know it's a halogen. It can only have 7. If we were to make those d electrons, we didn't drop back a ring or a period number, we would have 10 valence electrons too many. 10 valence electrons too many. Does everybody see that? Somebody say yes, or I don't know. Explain it a little better.
Yes. Yes.
Yeah.
Okay?
Can you explain that again?
Sure. Okay? Suppose we did not drop back a ring for the d electrons. So these triangles would be on the 4th ring instead of the 3rd ring. All right? Then, now we know we're drawing bromine, the halogen in the 4th period. I should only have 7 valence electrons. But if I move these 5 electrons to here, these 5 electrons to the 4th ring, I would now have 17 valence electrons. I would now have 17 valence electrons. All right? But we learned last class that the number of valence electrons in a neutral representative atom is equal to the Roman numeral group number. The Roman numeral group number for the halogens is 7. So I should only have 7 valence electrons. All right? Again, if I did not drop back the ring, I would have 17 valence electrons. 17. Similarly here, this 3D would be 40. I would have 4s2, 4d10, 4p5. That would be 17 valence electrons in my electron configuration. But I know I can only have 7. So this is why we must.
Got it. Makes sense.
Sorry? Sorry?
That makes sense. Thank
That
you.
makes sense? Okay, good. Okay? So you always got to drop back a ring. Now, when you're doing these, if you have your textbook, or you can check online also, because I'm going to give you an assignment where I think the assignment actually has 6 of these, but I'm only going to ask you to do 5. Okay? We'll save you a little bit of trouble there. But you can check the right electron configuration online or in the back of the book or whatever. Okay? Although I will tell you for like copper, they will have, for copper, it will be a little bit different. All right, I'm going to, so you want me to do one more here? One
Yes.
more?
Yeah.
Yes, please.
All right, we'll do one more. Let's do cesium. Cesium. Or the alkali metal in period, what period cesium in? 6? Right?
Excuse me?
Yeah, the alkali metal in period 6, which is cesium. Right? So
Okay.
55 electrons, right? 55
Mhm.
electrons. So this is going to get kind of crowded. So as always, we're going to begin in period 1. This will take us right to the end of class. I'm going to come over here a little bit. So period 1, 2 electrons, 1s2. 1s2. All right, 1s2. Electron counter goes from 0 to 2. All right? So then next element after helium is lithium, which is in period 2. So down here, period 2, S block, 2 electrons. S block, 2 electrons. Okay? Sorry, I forgot to put the 2 electrons here, lithium and beryllium. Now electron counter goes from 2 to 4. Okay? Next element after beryllium is boron, still in period 2. All right, so down here, period 2, boron's in P block. 6 electrons fit in P block. So I'm going to have boron, carbon, nitrogen, oxygen, fluorine, neon. Down here, second period, P block, 6 electrons. Electron counter goes from 4 to 10. 4 to 10. Okay. Next element after neon is sodium, which is in period 3, so a new ring. Hopefully I've left enough room to make 6 rings. Okay. Sodium's in period 3, S block, 2 electrons. So there's the 2 electrons, sodium and magnesium. Electron counter goes from 10 to 12. Not even close yet. Right, next element after magnesium, am I going too fast? You need me to slow down? Speak up. Next element after magnesium is aluminum, which is still in period 3, but in P block. So I don't need a new ring. Period 3, P block. So 6 electrons fit in P block. Aluminum, silicon, phosphorus, sulfur, fluorine, argon. Period 3, P block, 6 electrons. Okay, 6 electrons. Electron counter goes from 12 to 18. 12 to 18. Okay, next element after argon. Remember, argon should have 8 valence electrons, which it does. Next element after argon is potassium, which is period 4. So 4th ring. 4th ring. Right down here, period 4, S block, and 2 electrons fit in S block, potassium and calcium. Right, so period 4, S block, 2 electrons, counter goes from 18 to 20. Everybody caught up? Everybody caught up? Okay. The next element is scandium, which is in D block. So I'm dropping back a ring. I'm dropping back a ring. All right, and I'm going to put my triangles in red this time. All right, so period 3, D block. Okay, and I'm going to put 10 electrons up. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. All right, so there's my 10 electrons. And down here, I'm going to write 3d10. An electron counter goes from 20 to 30. And again, at 30, you should stop and check and make sure that you're at 3d10 at zinc. Okay, at zinc. All right. Next element after zinc is gallium. So now we're back into P block with normal period numbers. Normal period numbers. So, so we're back to period 4, 4th ring. Period 4, P block, and 6 electrons fit in P block. So gallium, germanium, arsenic, selenium, bromine, krypton. All right, so period 4, P block, 6 electrons. 6 electrons. Electron counter goes from 30 to 36. 30 to 36. We're at krypton. Inert gas should have 8 valence electrons, which this does. All right, next element after krypton is rubidium. Rubidium, which is in period 5. So I need a new ring. Period 5, I need a new ring. Okay. All right. So down here, period 5, S block. 2 electrons fit in S block, rubidium and strontium. All right, so down here, period 5, S block, 2 electrons, electron counter goes from 36 to 38. All right? Seems like we're still far away, but we're actually very close. 17 electrons away. We're actually very close, because D block has 10. All right, so after strontium, now we're back in D block again. Now we're back in D block. So I'm going to drop back a ring number. So instead of 5D, it's going to be 4D. 4D. And 10, so I'm going to write here 4D, 4D. Hopefully you can read my writing down there. I'm kind of running downhill. All right. Now, I forget the order of the elements. I remember the first one is yttrium, but I'm just going to put 10 triangles. 1, 2, 3, 4, 5. Oh, I'm going to put 5 on each side. 6, 7, 8, 9, 10. I believe That should put us at cadmium. 48 is cadmium. Okay, so 40, 10. At 10 electrons, electron counter is at 48. 48. All right, so at the end of 4D, and again, check and make sure that you drop back the ring, which we did. All right, now we're into P block. So back to normal period numbers. Right, so we're at 5P now. 5P. I don't have a periodic table in front of me. 49 is what element? 50 is 10. Indian.
49 is indium.
Right, indium. So we're at 5P now. 5P. I've run out of room there. All right, so we're down here, indium, tin. Lord knows what these other guys are. Just get 6 of them up here. All right, that should put us at xenon. So period 5, P block, 6 electrons. Electron counter goes from 48 to 54. Now we're home. One more electron. One more electron. Okay? One more electron. I'll give you a chance to get caught up. And the next element after xenon is cesium, which is where we want to be at. Cesium's in period 6, so I need a new ring. My last ring. My last ring. All right, so here I'm going to write period 6, S block. Now, 2 electrons fit in S block, but I only need one more. I only need one more. So 1 electron for cesium. And here I'm going to put 1 electron. The electron counter goes from 54 to 55. Okay? Now, I'm going to rewrite the electron configuration before I do anything. So, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 6s1. Sorry I ran out of room there. 6s1. Right? So I'm going to rewrite it before I do anything. And hopefully I didn't screw it up this time. But if I did, we'll catch it. That's why we count the electrons. So, okay, so I'll give you a chance to copy that down in purple. Yeah, the smoke is clearing up. When I came home, geez, it was like standing right next to a campfire. You guys know there's something like 8 forest fires in the area. All right. Does everybody have this rewritten electron configuration?
Yes.
Yes.
Okay. All right. So we're going to count electrons, 55. And again, what if you drew these all the same? You had to count them one by one. Count 55, you'd go crazy. But we have them separated real nice. There's 10 here, right there, the d electrons. 10 there is 20. All right? 2, 4, 6, 8, 10. There's 30, 31, 31, 37, 43, 49, and 6 more is 55. So we're good there. We're good there. Again, you have them separated like that, you can count them real fast. So let's add up the superscripts here. 2, 4, 10, 12, 18, 28, 30, 36, 46, 48, and 54, and 55. So we're good there. We're good there. Now, cesium is an alkali metal. It should have 1 valence electron. There it is. 1 valence electron on the 6th ring. Down here, I don't have much room, but I'm going to underline the highest period number. There it is, 1 electron on the 6th ring. Right? Now, we should also check that we did, in fact, drop back 1 ring for the d electrons and 1 period number in our electron configuration. So here I have 3d and 4d. So that's good. And here I have my 3d, and then 4s2, 4p6, 4d10. So I did, in fact, drop back a ring here, and period numbers in the electron configuration. Okay? Any questions or comments? Any questions or comments? Nobody has any questions or comments? Okay?
I have a question.
Yeah, go ahead.
For 6s1, how did you only get one for the electron?
Instead of 2?
Yeah.
Do you have the periodic
Because
table in front of you?
Yes.
Take a look where cesium is. It's in the first position in S block, group 1, right?
Yes.
If we were drawing barium, then we would have 2. Does that make sense?
Okay. Yeah.
Because we were stopping at cesium. We were stopping at cesium. Right? If we were stopping at barium, then barium is at the alkaline earth, the second position in S block. Remember, the alkaline metals occupy the first position in S block. The alkaline earths occupy the second position in S block. So for the alkaline metals, you only have 1 valence electron in S block. And for the alkaline earths, then you would have 2 valence electrons in S block. Right?
Okay.
Nobody else has any questions. Always check those number of valence electrons. They will help you. You know, so look, you should check 3 things, right? Total number of electrons, number of valence electrons, and D block. If you check those 3, you should never get any of these wrong. You should never get any of them wrong. And I will tell you, I do count them up. I do count them up. Make sure you have the right number. Okay? Any other questions or comments? Any other questions or comments? Okay? Then I'm going to stop recording and we can talk about some other things if people need to. So I'm going to stop recording here.